Hey everyone, welcome back to XYZ Architect. Today I'm excited to share an example video showcasing how your programs will be reviewed. This video features my own measurement program, which I'm free to share as I'm not bound to any confidentiality agreements. I want to highlight that before reviewing any of your programs, we'll have a detailed discussion to ensure complete transparency and agreement of confidentiality terms. If you're interested in participating, please leave a comment below or contact me directly at this email. So, without wasting any time, let's start the first video of many, I hope, from the series Check the Program. Okay guys, so we are in Calypso now and we are going to start checking the program. The first thing that I'm going to do, and what I usually do when checking a measurement program, is going and see exactly what the drawing requires, right? So, because this is my program, I don't have a problem in showing the drawing. This is a drawing that I have done for the purpose of this video. And the first thing that I'm going to see is the datums, and I can see now here that datum A is somewhere around here. So let me make this a little bit so it's on this surface from here. Then I'm going to search for another datum, right? So datum B is here. And I think this is it for this type of a program. So not much going on here because I didn't want to make a very long video of this, and that is why I have checked and I have picked this type of part. But I think it's enough for you to have an image of what you are supposed to see from this series. So datum A, datum B, actually this is the coordinate system, datum A, datum B, and now I'm going to check the program. So let's see exactly the alignment, how it is done. Okay, we are going inside. We have datum A. Let's see, we have here datum A, we have the strategy. The strategy for datum A is scanning. This is very good because as you saw on the drawing, let me bring up the drawing also, we have also flatness here. So datum A should be scanned. Yeah. Go and see in your measurement programs if you have GD&T. If you have GD&T like flatness, parallelism, and perpendicularity, not for true position, but yeah, profile of surface, then you should scan the part, okay? You should scan the features because you have more data, the data will be more accurate, and you can show more to the people that needs to understand what is going on with the part. From my point of view, datum A here is okay. We even have the 380, so it goes a little bit further than 360. The diameter is like this, 650. Yeah, it's good. This is good. Then we have an origin. Okay, so we have an origin. This is an intersection, as we can see here, an intersection between datum B, that's the cylinder from here, and datum A, and the origin is set right here. Good. So the alignment so far looks good. I think I like it, and it's okay. Of course I like it. It's my alignment. So the alignment looks good. What I didn't do, but I didn't do on purpose, was the start alignment. Okay, so if I received, for example, let's say that I received this program, and now I've looked at the alignment, okay, at the base alignment, and I don't have on the drawing, as you saw earlier, we don't have the secondary direction, right? Because datum A and datum B is actually, they have actually the same normal direction, right? So datum A being the plane from here, this is the normal direction in this direction, and datum B being the cylinder, it has the same direction. The axis of the cylinder will have the same direction. So you don't have the secondary direction. So what I recommend, because clearly if you don't have a device or something to sit this part on the CMM table, then clearly you will not sit it the same, because it's a part of revolution, right? So you can sit it like this, you can sit it like this, next time you will sit it like this, and so on. I mean the revolution, right? So I do recommend making a start alignment. We have these holes from here that we can use, and let's see, I think we already have. So let's say that we are going to use the first one and the, let's see, I think this one or this one. Yeah, the first one and the 11 cylinder. So what I'm going to do now is create an intersection between cylinder number 1 from here. So we have cylinder, sorry, not that one, cylinder number 1 and datum A, and then create another intersection, cylinder 11, but I think I can sit here just like this, and another intersection. This is just for you to see exactly what I did, right? But I already did this here. So I have the intersections right here, and I did create a 3D line between the intersected points. This will help because, let me just delete this too. Okay, and let's see if I did the start alignment. Yeah, I did it. So this will help, right? Because no matter how you sit the part on the CMM table, you will get exactly the direction that you need. Good. Next, what we are going to check is if we have secondary alignments, right? Why do we need to check if we have secondary alignments? Because usually people work in two ways. The first way is by using secondary alignments to catch the part, and the second way is by using formulas to catch the part, to catch the features, not the part. But there is a third way, of course, by people don't use anything, they don't use formula, they don't use secondary alignments or help alignments, but you know as I do that some parts are very deformed and the real world will not be the same as the CAD model, never. So let's see now, what do we have next? So we have datum A, datum B, this we checked. We checked the strategy. For datum B, I don't think we checked the strategy. Let's see. 21 points. Since we have a bigger diameter than the depth, I don't think there's a problem if this would be also one circle path, but it's good as it is. It's not a problem, because if for some reason we have draft here, then it will catch a draft, and it's more okay like this. So let's see, the origin is here. Then what I did was the circle for the diameter 609.6, but I've choose to define the names of the features like this for you to understand that it's way easier to identify the dimension from the drawing. 609.6 is right here, and you can identify it very, very easily. But I do recommend setting numbers on your dimensions from the drawing to better understand and to better identify them. And it's way easier than setting dimensions, because you can have another 609.6, and then what do? Which one is it? But for now it's fine. It's just an example so you can understand. But yeah, the recommendation from my side, go and number the drawing so it's easy for you to identify the dimensions. Let's see the strategy for this one also. Okay, so we have the strategy right here. Clearly this is left default. What do we have to do here? Just the diameter. Let's see the drawing again. So we have the diameter and nothing else. For this diameter, from my point of view, 21 points, equally distributed, is just fine. But it seems that we don't have any secondary alignments or any formula used for this. Now, yeah, this is actually a problem, because notice that the surface from here is very thin, and yeah, you might have problems. You might not get exactly what you need. If the surface is, for example, smaller, then you might catch the circle from here, you might catch it on this surface that has a draft angle, and you will not want that. So my recommendation for this one is to make here a plane, but we already have one. Plane from here, and it's very simple, because the plane from here, I think it's, I don't know if the strategy, the circle path, okay, the circle path is fine. It's using the cylinder from here, so it should be safe to do it like this. We don't need a help circle or something like this, although you can use it, no problem. You can make a circle near this surface first, and then use the circle to catch the surface from here, because this is also narrow, the surface from here. So let's do that first, because it's more safe to work like this than just in a base alignment. Let's use this circle. So it's kind of, I think it's I don't remember the thickness. Just a second. We have here 150.8. So if I go 145, I think it's fine. Like this, yeah. This is a help circle for dimension for the plane. plane, let's call it plane 1 because it's this plane from here, and the strategy will be 7 points just to identify the surface. Now let's move this here, let's move this here, and let's choose the origin of the circle on X and on Y. The strategy for the plane is, I don't think it's very good because this is a very high speed, so 5 millimeters should be enough. 1000 points because it's scanning, because we have the parallelism, so it's okay to be scanned. And let's set here 380 to go above the 360 for the strategy of circular path. Okay, and now let's take this one. Oops, just a second, because on this one I forgot to do something. So let's say that we want a formula for the diameter as well, and we choose the diameter plus, let's say 5. That's too little, 10 millimeters. So now it looks good. Now you will catch the surface, no problem. Then let's also see the circle, and we want the circle to take the z-axis from the plane plus 2 millimeters. I think that's not enough. Say 5 millimeters. No, 8 millimeters. I think this is it. So now it's clear. Now your circle will be found. Okay, and what do we have next? We have the cylinder. So it's good that we have the cylinders. We have here the circle. Just a second, because we have also this type of circle. We don't need any help from these ones. 21 points, single points. This is just for the diameter, right? Because it's circle diameter 812.8. Let's see. 812.8. It's fine. Tolerances are okay. Actually you have to check also the tolerances and so on, because when you check a program you have to check it from the basic things to the more complex things. Okay, so keep in mind that you don't have to skip checking the things that you think it's fine. This is from my experience. The diameters are done. We have also the cylinders. Okay, this is the cylinders from here, so we have the cylinders for this one. And I think we could use the diameter from them for each of them and the true position. No problem on this side it's fine, but you could use, for example, on the cylinder, because this is a pattern, you could use a pattern. For example, let's say that we have this cylinder from here, and let's say that we want to use a pattern. And for the true position, unfortunately, the true position you will have to evaluate it as single, because we don't have here the common zone, right? So although we have 20 times, you don't have here the common zone to say that it's a polar pattern or it's a pattern, okay? So that's why you don't have to do it as a pattern. And let's check if the nominals for the true position are correct. So the nominals are right here, and we need also the radius. The radius is here and the angle is here. So we do have a true position of polar true position. Let me just delete this one, the example. This one's as well. And I think this one we should say option, because we don't do it as a pattern. And let's just delete the pattern and options, and okay. And now it's back to normal. So let's check out the nominals. We have the nominals. The radius is 374.65. I think this is okay. Don't be afraid to use a calculator. It's not a problem. I use it all the time and I'm not embarrassed of this. 749.3. Let's see. 749.3 divided by 2, 374.65. That's correct. And we have the also the 27. Okay, that's very good. Then we have 45, 63, and so on, because the CAD model knows the nominals, right? And then it goes on the other side, and the dimensions are with minus, and it's fine. And we also have the parallelism right here and the flatness. Yeah, so yeah, the program is good. Now that you have an idea, now you can have an idea, of course, of how I check the program. I usually check also the multiple report if the program has one. I use to see if the standard protocol is used or you have a dedicated report. I can also support you with that also if you need and want. I can help you with the mark characteristics. I can help you with the header parameters and so on. And I check also that. And very important, results to file. I check if the measuring points are activated or not, because this is also very important when you recall the results, but you already knew that. Okay, so yeah, I think this is it. What I also can check is the stylus angle, and I can also simulate to see if the program works or not, or if you have collisions or not, and so on. But this will be done in another time, and this will be done on a measurement program from you guys. So, what do you say? Do you have the courage? Do you want me to check your programs? And are you open to learn with me together? What do you say? Can't wait for the real thing to come. Can't wait for your programs to come. See you next time. Thank you for your support, and I'm looking forward for receiving your programs and helping you improve your CMM programming skills. I value your trust and collaboration. Remember that by sharing your programs, you're contributing to a community that benefits from shared knowledge and experience. Don't forget, until next time, learn as much as you can.